So there are 5 different properties of parallelograms that we can use to determine whether or not something is actually a parallelogram. So the first thing is that in order for it to be a parallelogram, the opposite sides are parallel. So if I have a parallelogram here, what this means is that this side on the left and the side on the right are parallel. And it also means that the top and the bottom are parallel to each other. Remember, parallel means they never intersect. Number 2, the second thing is that the opposite sides are congruent. That means the opposite sides are also equal. So if the left side is x, the right side is x. If the top is y, the bottom is y, because they're the same. Number 3 is that opposite angles are congruent. So using arcs, I can show the bottom left and the top right are going to have to be congruent, and the top left and the bottom right are going to have to be congruent. Number 4 is that consecutive angles are supplementary. If you recall from the last lesson, supplementary means, I'm going to write this in blue right below it, is that they add up to 180. And consecutive means next to each other. So the 2 angles on the bottom, the 2 angles on the left side, the 2 on the top, or the 2 on the right side, each of those pairs is a pair of consecutive angles. The 5th and final requirement in order for something to be a parallelogram is that the diagonals bisect each other. The diagonals bisect each other, and that means they split each other in half. Now, there's a couple of different combinations of these that we can actually use to prove that they're parallelograms. So the first one says, if both pairs of opposite sides are congruent, or of a quadrilateral are congruent, then we know for sure it's a parallelogram. So all that's saying is that if I have something with 4 sides, and I'm told that the left and the right are congruent, and the top and the bottom are congruent, then by definition it must be a parallelogram. So that's one way. The second way to know if there are in fact a parallelogram is that if one pair of opposite sides of a quadrilateral is parallel and congruent, then the quadrilateral is a parallelogram. So if I have a shape here, and I'm told that the left and the right are congruent, and I'm also told that the left and the right are parallel, remember those arrows represent parallel, then it has to be a parallelogram. The third statement says that if both pairs of opposite angles of a quadrilateral are congruent, then the quadrilateral, that also makes it a parallelogram. So if I have a shape, and what I'm given is I'm given that the bottom left and the top right angle are congruent, and the top left and the bottom right angle are congruent, then it has to be a parallelogram. The next option says that if consecutive angles of a quadrilateral are supplementary, then the quadrilateral is a parallelogram. Now, this one's a bit tricky because in order for this one to be true, every pair has to be supplementary. So every consecutive set of angles. So the two on the bottom have to be supplementary. The two on the right side have to be supplementary. The two on the top have to be supplementary. And the two on the left also have to be supplementary. So if that's true, that every pair of consecutive angles is supplementary, then it is a parallelogram. All right, and the last statement says that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if I have a quadrilateral with my diagonals drawn in, and I'm told that this half and this half are the same, and this half and this half are the same, then it, by definition, must be a parallelogram. So we're supposed to complete the proof below to show that ABCD is a parallelogram. So we have to look at what we're given. Well, the first thing we're told is we're given this little mark here and this little mark here. So what we know is that AE is congruent to CE. That's what this first step says. The second thing we're told is that this angle and this angle are congruent, and that's what the second one says. BAE is congruent to CDE. So now they're going on to say that BEA, which is this angle right here, is congruent to CED, which is this angle right here. Well, the reason that we know that is true is because in semester 1 you learned that opposite angles, which are angles that are across from each other, opposite angles are congruent. That is how we know that statement is true. So now they're moving on to say that triangle BEA, well, that's this entire side over here. All of this is congruent to triangle CED, which is this triangle over here. Well, think about what you've been given. You know that this angle and this angle are congruent. You know that this side and this side are congruent. And the last thing you're told is that this angle and this angle are also congruent. Well, think back to geometry, semester 1. One of the things you learned was that if you have an angle, a side, and an angle, or corresponding angle, sides, and angle of two triangles that are congruent, then they're congruent as well. That's called the ASA, the angle, side, angle postulate. There was a bunch of different postulates you learned. Angle, angle, side, 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 angle, side, angle, and side, angle, side. And all of those are different ways we can prove that that triangles are congruent. Okay, so now we've got to they've given us the reasons, so we've got to figure out what they're telling us now. So think about what you just proved. You just proved these two triangles were congruent. Now you're saying corresponding sides of congruent triangles are congruent. So we've got to say that we're saying that two sides are the same, and we're trying to eventually prove this is a parallelogram. Well, in order for it to be a parallelogram, we have to know that AB and DC are congruent. Well, that's what we know now. Because we know these two triangles are the same, then by definition, this side and this side must also be the same. So our next statement that we can say is that AB, side AB, is congruent to side CD. And then Our next reason that it gives us is that when two lines are cut by a transversal and their alternate interior angles are congruent, the lines are parallel. So let's think, what do we need to be parallel? Well, if you think back to your reasons or the ways we can say something is a parallelogram, the second one you wrote, the one that was on page 7, said if one pair of sides was parallel and congruent, then we could know it's a parallelogram. Well, what they're telling us here is that these two lines, I'm going to color this in pink, these two lines are cut by a transversal. They're calling this diagonal here a transversal. And we're told that this angle and this angle are the same, then what that means is that those two lines are in fact parallel. So that's what we now know, is we know now that AB is parallel. We do the symbol for parallel is two vertical lines to CD. Well, now that we know that that AB and CD are parallel and AB and CD are congruent, then we can say that ABCD is a parallelogram. Because it said if a quad has one pair of parallel and congruent sides, then it must be a parallelogram. Then it is a parallelogram. So for the next page, it asks you to find the value of x that makes ABCD a parallelogram. Well, we were told in order for it to be a parallelogram, these two angles had to be supplementary, which means they have to add up to 180. So I need to write that 120 plus 3x equals 180, and then I need to solve this for x. X is on one side, numbers on the other. To get x by itself, I need to get rid of the 120. So I'm left with 3x equals 60. And then I'm going to divide both sides by 3, and I get that x equals 20. So as long as x is 20, then this is in fact a parallelogram. Alright, 17, we're supposed to describe how you know that ABCD is a parallelogram. Well, we literally just proved that statement on the previous page. So we're going to move on to the checkup. Alright, so number 1, it says to find the value of x that makes ABCD a parallelogram. In order for it to be a parallelogram, my opposite sides have to be congruent, which means that 18 has to equal 4x. So I need to solve for x, so I'm going to divide both sides by 4, and I get that x equals 4.5. So as long as x is 4.5, then these two are this is in fact a parallelogram. Number 3, same problem, or same type of problem, a little bit easier to work out. In order for it to be a parallelogram, again, my opposite sides have to be congruent, so that means that 15 has to equal x plus 4. So I need to get x's by themselves, so I'm going to subtract 4 from both sides. 15 minus 4 is 11, so as long as x is 11, then this is a parallelogram. Number 5, if I want to know it's a parallelogram, well, things about angles. I know the opposite angles have to be congruent, which they tell me that because they tell me that these two are both 3x minus 98, and the other two are both x plus 20. I also know that my consecutive angles, so the two that are beside each other, doesn't matter which pair, have to add up to 180. So I'm going to pick one of those pairs. I'm going to pick the bottom two. If I add them together, they must equal 180. So I'm going to write out that x plus 20 plus 3x minus 98 must equal 180. So I need to get all my x's on one side, my numbers on the other. First, I'm going to go ahead and combine my like terms. I have a plus 20 and a minus 98. And I have a x and a 3x. X plus 3x is 4x. And 20 minus 98 is negative 78 equals 180. So I'm still trying to get x by itself, so I'm going to add 78 to both sides. So I get that 4x equals 258. And the last thing I need to do to get x by itself is I need to divide both sides by 4. And when I divide 258 by 4, I get that x equals 64.5. So as long as x is 64.5, then this is a parallelogram. All right, number 7. Well, I know that my opposite angles must be congruent. Well, obviously 130 and 130 are the same, so that means 50 must equal 5x. To get x by itself, I'm going to divide both sides by 5, and I get that x equals 10. Number 9. Again, I know that consecutive angles must add up to 180. So that means that 78 plus x plus 10 must equal 180. I can combine my 78 and my 10. So I get x plus 88 equals 180. And then I can subtract 88 from both sides. And I am left with x equals 92. So that's what it would take to make this a parallelogram.